This simulation allows us to explore how the speed of a falling object is affected by the mass of that object and its interaction with the surrounding air. We've already collected some data by keeping the mass the same and varying the parachute size to change how the object interacts with the air. Let's try one more parachute size. To make a graph, click on the Graph button. The graph doesn't yet have any horizontal or vertical axis labels, so the data is initially scattered randomly over the graph area. Let's look at how velocity is affected over time. To set the graph axes, we just drag an attribute from the table to either the horizontal or vertical axis. Now we can see the velocity of the falling object across all of our trials on one graph. You can zoom into a graph by double-clicking and zoom out by shift double-clicking. The axes can be changed by dragging near either end, which changes the scale, or near the center, which shifts the visible range. If you get lost while doing this, you can always tell the graph to auto-scale to the current data set using the gear menu. We can color the dots by dropping another attribute onto the middle of the graph. Let's try parachute size. Numerical attributes will typically result in a color gradient indicating the range, but you can say that each different value should be its own category or color by clicking on the attribute label in the graph and selecting Treat as Categorical from the menu. You can change what attributes are displayed on the graph by dragging over the existing ones, or by clicking on the attribute label and selecting a new attribute from the menu. You can easily focus on one set of data by using these toggle switches. Let's take a look at the relationship between the size of the parachute and the highest speed of the falling object, also known as its terminal velocity. One way to help quantify this relationship would be to fit some kind of function to this data. A movable line is available from the gear menu. You can drag the line around to find the best fit for your data and see an equation that calculates the relationship. In this case, a line doesn't look like a good fit. We can also plot a function on the graph and use sliders to represent coefficients that are part of the equation. This data looks like it might be an inverse relationship, so let's try plotting that kind of function. We select Plot Function from the menu. For inverse relationships, the simplest function would be y equals some number, let's call it k, over x. To adjust k, we'll use a slider and change it to set k, as well as adjust the scale of the slider to be appropriate for the values in this graph. Now we can adjust the slider to see if we can fit an inverse curve to this data. It looks pretty good. Notice that all graphs are linked together. Highlighting data in one graph highlights relevant data in other graphs and the table. Let's look at how this can be used to explore other kinds of data. Here is a random sample of data collected via the census about people in California. Let's create a graph to show the range of salaries people have in this data. By setting only one axis of the graph, you can visualize the full range of values in your data set and get a sense of how many data points there are at each level. This data includes young children, so let's filter them out. The easiest way to do that is to use a graph of age. First, we make a graph of age distribution. Then let's select those who have not had a chance to be in the workforce for very long, perhaps people younger than 20. We go over to the other graph, which has the under 20 data highlighted too, and choose Hide Selected Cases from the Gear menu. We can also filter out married people who have no income, as they likely have a spouse who does. So let's make a graph of marital status versus income. First, I'll drag income here, and then marital status here. Then select those who are married and only show their data. Then we can select those married people who have no income and remove these from the data set we want to focus on. We now have a reasonable set of data representing those who are in the workforce or looking for work. When showing a distribution type graph, there are options for showing the mean, median, and other aggregate values. Let's show the average or mean salary. Now let's add educational attainment to our income graph. We can see that most people with high salaries have some university training. Let's focus on those high income people and explore gender. Since we have the highest income data already highlighted, we can show only that data by selecting Hide Unselected Cases from the Gear menu. One way to highlight gender is by making another graph and using it to highlight which data points represent men or women. We can see that men are much more frequently represented in higher income jobs. Graphs in CODAP can serve to visualize data, which is the typical use, but can also be used to see relationships between different visualizations and as filters to narrow down larger data sets into meaningful subgroups for analysis.